Hello students, welcome to the channel Chemistry is Fun. Today's video is about the calculation of hybridization for organic compounds. So before that, let's give a brief introduction about what are organic compounds. So organic compounds are those which contain carbon as their central atom. Carbon element is present in fourth A group and second period in the periodic table. Okay. Its atomic number is equal. So atomic number is usually represented by the symbol Z or Z. Its atomic number is 6 and we write the electronic configuration as 1s2, 2s2, 2p2. Now when no energy is applied or when the atom is in its ground state, the configuration is 1s2, 2s2, 2p2. You can write the arrow representation like this. So it has got 2 electrons in the 2s orbital, 2 electrons in the 2p orbitals. Now when the energy is supplied or the atom gets excited and one of its electrons from 2s moves to 2p. Now the configuration is 2s1, 2px1, 2py1, 2pz1. So this is the excited state configuration for carbon, 2px1, 2py1 and 2pz1. Now it will use these four atomic orbitals for undergoing hybridization. So the possible hybridizations for carbon are sp, sp2 and sp3 according to the types of bonds present in the given molecule. Let us look at the simple example. We have methane. CH4 is methane. Carbon has 4 single bonds around it, that is 4 hydrogen single bonds. So when there are 4 single bonds, the total number of bonds is equal to 4 and the hybridization is sp3. Okay, and what is the formula to calculate hybridization here? Hybridization is equal to number of sigma bonds plus number of lone pairs. So in case of methane, there are 4 single bonds with 0 lone pairs. So it is 4 plus 0 equal to 4. So the hybridization of methane, carbon in methane is sp3 hybridization. Similarly, if you look at ethylene, which is CH2 double bond CH2. If we expand the structure, what are we going to get? This carbon is surrounded by 2 hydrogens on one side and bonded with a double bond on the other side. Now this is one more carbon with 2 hydrogens on this side. So we need to look at each and every carbon for hybridization. So this is the first carbon and this is the second carbon. Now look at the first carbon alone. There is one single bond, and one double bond. So 1, 1, 1 together it is 3 bond pairs. So when the number is equal to 3, then the hybridization is sp2. So the first carbon's hybridization is said to be sp2. Similarly, the second carbon also has got 2 single bonds with 2 hydrogens and one set of double bond with carbon. So the hybridization of both the carbons in ethylene molecule is sp2. Similarly, if you look at ethyne or acetylene, the formula is C2H2. So if we expand, we get a triple bond between two carbons and a single bond with hydrogen. So look at each and every carbon separately, first and second one. Triple bond is together considered as a single entity and the single bond is considered as one entity. So 1 plus 1 it is 2. So the hybridization at the first carbon is sp. Similarly, the second carbon also has got hybridization is equal to sp. So what you can conclude from this, when there are all single bonds around the carbon, then the hybridization is sp3. Okay, when there are all single bonds around the carbon, then the hybridization is sp3. When there is at least one double bond, then the hybridization is sp2. when there is at least one triple bond, then the hybridization is sp. This is the basic condition and the three possible hybridizations for carbon compounds. Let us look at few more other type of molecules or groups. The another compound example is alene. Okay, what is an alene? When there is continuous double bond in a 3 carbon compound. This is the formula of an alene or the structure of an alene. Okay, so we need to look at the hybridization of each and every carbon. Let us number it 1, 2, 3. Now look at the first, let us expand the structure. So there are two hydrogens on the first carbon and a double bond. Middle carbon is connected to two double bonds on either side, and the third carbon has got again two more hydrogens. Now count them as a individual entities. Surround this particular carbon, this is one entity, this is one entity, and this is one entity. So 1 plus 1 plus 1 is 3. When the total value is equal to 3, the hybridization is sp2. Now look at the middle carbon, that is second carbon. There is a double bond on one right hand side, another double bond on left hand side. So 1 plus 1 you have to consider it as 2. When the value is equal to 2, the hybridization is sp. Similarly, look at the third carbon. There's one CH bond, one more CH bond, and one C double bond C double bond. So altogether it is equal to 3. So the hybridization is sp2. So in any carbon compound, when there are more than one carbon atoms, you have to consider each and every carbon atom as a single central atom and find out the hybridization at each and every carbon. Okay, now let us look at one more molecule, that is vinyl acetylene. Another example here is vinyl acetylene. What is the formula of vinyl acetylene? Let us look at it. Vinyl group is CH2 double bond CH. This group is called vinyl group. Now to this group, if you add an acetylene or alkyne group, then such compound is called vinyl acetylene. So this is the formula of vinyl acetylene. Okay, now we need to look at each and every carbon again. So 1, 2, 3 and 4. Now let us expand the structure, then we can find out the hybridization easily. Okay, now on the first carbon we have CH2 single bonds and a double bond. So 1 plus 1 plus 1 plus 1, it is 3. So this carbon has got sp2 hybridization. As you do more and more examples, you can easily identify by looking at a double bond attached to the carbon. Since there is one double bond here, then it is sp2 here also. Now this third carbon is attached to a triple bond, so it has to be sp hybridization. Similarly, the last carbon is also attached to one triple bond, so it is sp hybridization. This way, by looking at the molecule itself, you can identify the hybridization readily. And let us look at one more example, that is divinyl acetylene. Divinyl acetylene. So vinyl acetylene we have seen, we need to look at divinyl acetylene. So there has to be acetylene groups on either side. Sorry, vinyl groups are to be 2 and acetylene group should be in the middle. So this is one vinyl, this is another vinyl on either side. Now this has to be connected to an acetylene in the middle. So vinyl group on left hand side, vinyl group on right hand side. In between there is an acetylene group. So this is an example for divinyl acetylene. So now this carbon is attached to a double bond, so it is sp2. Next carbon is also connected to one double bond, so it is sp2. This carbon is connected to one triple bond, so sp. This carbon is also connected to a triple bond, so it is sp. Now this carbon is connected to double bond sp2 and sp2. So this way, in any given molecule, you can find out how many carbon atoms are having sp hybridization, how many carbon atoms are having sp2, and how many carbon atoms are having sp3 hybridization in a given organic compound. So this is a simple method to find out the hybridization for organic compounds. Hope this video is useful. Thank you and subscribe the channel.